A nuclear bomb was detonated in 1979 in the Prince Edward Islands, and the strangest thing about it is that no one in the whole world knows who set off the nuclear bomb. Investigation has been carried out, and every time it leads to inconclusive results. So, for 46 years, no one knew who set off a nuclear bomb. Until now. In today's video, I finally reveal what happened and who was responsible for that nuclear detonation. September 22nd, 1979, roughly near the Prince Edward Islands, a tiny patch of land halfway between South Africa and Antarctica. Vela 6911, an American satellite orbiting Earth, saw something it should never have seen. A silent flash of light, far from any known battlefield or nuclear testing ground. But this wasn't just any flash, it was the infamous double flash, the signature of a nuclear detonation. A brief burst of intense light so fast it was nearly missed, followed by a second, longer flash. The kind of flash that only ever came from one thing, and one thing only: a nuclear bomb exploding in the open air. There's no civilization for hundreds of miles, no military bases, no airports, nothing. Just black ocean and blue sky. And yet someone, somewhere, detonated a nuclear bomb. And the crazy thing is that till today, no one knows who did it. When the Vela 6911 satellite registered that infamous double flash, it wasn't a lucky accident. That satellite wasn't drifting aimlessly through space. It was there for one very specific reason: to catch exactly this kind of moment. Back in the early 1960s, deep in the paranoia of the Cold War, the US needed a way to make sure no country could cheat on nuclear treaties. So it built a series of satellites known as the Vela system. Vela means watchman in Spanish, and that's exactly what these satellites were. Silent guards orbiting Earth, watching for signs of a nuclear explosion. By the time Vela 6911 was launched in 1969, the technology was already in its second generation. Unlike earlier military satellites, these weren't designed for spying on troop movements or enemy bases. They were detectors, pure and simple. Their job was to recognize one very specific thing: a nuclear detonation in the atmosphere or in space. To do that, the Vela satellites used a unique set of instruments. Most important were their optical sensors, called bang meters, a name so strange it almost sounds made up. These bang meters were designed to detect bright flashes of light, but not just any flash. They were tuned to pick up specific patterns, and only one pattern truly mattered: the double flash. The first flash is sharp and blinding, lasting just milliseconds. It's caused by the initial fireball from a nuclear blast. Then there's a brief dip, followed by a longer, dimmer second flash. That one comes from the expanding shockwave as it heats the surrounding air, or space. It's a signature nothing else produces. Not meteors, not lightning, not solar flares, just nukes. That's the pattern Vela 6911 picked up on September 22nd. But optical sensors weren't its only tool. The satellite also carried X-ray and gamma-ray detectors to catch high-energy radiation that a nuclear explosion hurls into space. And if the blast was strong enough, the satellite could also register electromagnetic pulses, massive bursts of energy that can fry electronics and disrupt communications. So when the signal came in, it wasn't just a flash of light, it was a pattern, a fingerprint. And according to the data, it matched over 40 previous above-ground nuclear tests that had already been confirmed. In the 10 years since its launch, Vela 6911 had never made a mistake. It had detected multiple nuclear tests and had never once registered a false positive. Not once. That kind of reliability matters, especially when you're accusing a nation of secretly detonating a nuclear weapon. Immediately after the 1979 flash, analysts at Los Alamos and Sandia National Laboratories began poring over the data. They knew exactly what the signature of a nuclear blast looked like. They'd seen it dozens of times before, under lab conditions, under test detonations, even during hostile monitoring of Soviet and Chinese tests. This one was no different. The optical sensors showed a classic two-pulse light curve, just like in verified bomb tests. The timing between the pulses was consistent. The brightness ratio between the first and second flash matched previous nuclear events. And the satellite was working perfectly. No degraded sensors, no data loss, no signs of malfunction. The Vela system had done its job. There were even faint supporting signals from other monitoring systems. In the South Atlantic, a network of underwater hydrophones used to track nuclear detonations beneath the sea picked up a barely audible acoustic signal that might have been consistent with an explosion. It wasn't strong enough to confirm anything on its own, but it lined up time-wise. Same with a weak radio burst caught by ground stations. Short, sharp, and right on cue. After the flash, a team at Los Alamos dug deeper. They reconstructed the light curve using archived test data to see if there was any way a natural event, like if a meteor or lightning, could mimic what the satellite saw. Nothing matched. Then came the instrumentation checks. Maybe the satellite glitched. After all, it was 10 years old, long past its expected service life. But the diagnostics showed no faults. The sensors were fine. The onboard memory was intact. Power systems were normal. The satellite hadn't experienced any unusual vibration or radiation spikes at the time of the flash. There was no mechanical reason to doubt the reading. Even the design of the Vela system made false positives incredibly rare. The satellites were built in pairs, one for the optical sensors, one for backup and redundancy. And Vela 6911 wasn't working alone. Other Vela satellites were still in orbit, collecting overlapping data. That's how thorough the US had been. When it came to nukes, they weren't taking chances. And yet, boom, a silent boom. The alert pinged back. At Los Alamos, at NORAD, at the Pentagon, wherever the signal landed, the reaction was instant. Panic. Because nuclear testing was banned. The Limited Test Ban Treaty, signed back in 1963, had forced nations to stop detonating bombs in the atmosphere. Underground was one thing, but a test in the open sky? That was a provocation. And whoever did it had to know the US would see it. So who would take that risk? Was it the Soviets, China, Libya, North Korea, Israel? Behind closed doors, the questions piled up. Why there? Why then? The Prince Edward Islands weren't chosen by accident. That stretch of ocean was one of the most remote places on Earth, nearly invisible to ground-based sensors. No nearby population, no easy witnesses. If someone wanted to hide a bomb, that would be the place. The man sitting in the White House at the time, President Jimmy Carter, wasn't just any president. He was a nuclear engineer by training. He understood the data. He knew what a double flash meant, and more importantly, what confirming it could unleash. It was September 1979. Cold War tensions were smouldering. The US was still reeling from Vietnam and Watergate, and Carter was staring down a tough re-election campaign the following year. He'd staked much of his presidency on diplomacy, arms control, and avoiding war. This wasn't just a national security issue, it was a political landmine. If the US confirmed a secret nuclear test, especially by a supposed ally, it wouldn't just spark international outrage. It could unravel years of non-proliferation efforts, rupture alliances, and ignite fresh tensions in a world already on edge. And if Carter's administration was seen as soft, indecisive, or even worse, complicit in covering for an ally's rogue test, it could end his presidency. So as the scientific evidence poured in, a very different process began behind closed doors. Meetings were held. Urgent cables were exchanged. The Department of Energy wanted transparency. So did many at the Pentagon. The CIA, however, was divided. Some officers leaned toward confirming the test, arguing that silence would only embolden future violations. Others wanted to downplay the event, fearing the geopolitical blowback. Then came the media. Leaks started to drip into the press. Reporters at outlets like the Washington Post and the New York Times caught wind of the satellite detection. Sources inside the intelligence community confirmed that a possible nuclear test had been registered. The White House, caught off guard, scrambled to control the narrative. Their official statement? The flash was an unusual reading, just a blip, an anomaly, nothing to panic about. Privately, Carter and his advisors were already shaping a different response. They knew they couldn't just brush this under the rug, especially with journalists circling and foreign governments quietly demanding answers. So they launched a panel, a scientific advisory group designed to evaluate the Vela data. But the goal wasn't to find the truth, it was to make the problem go away. This group would become known as the Ruina Panel, named after MIT professor Jack Ruina, who was tasked to lead it. But behind the scenes, the panel was neutered before it even started. They weren't given access to the classified satellite data. They weren't allowed to interview key intelligence personnel. They weren't shown corroborating evidence from other detection systems. In short, they were handed a sanitized, incomplete version of the truth and expected to deliver a politically safe verdict. And that's exactly what they did. In May 1980, the Ruina Panel concluded that the double flash was likely not a nuclear event. The official verdict was inconclusive. They floated alternative explanations, sunlight reflections off satellite debris, lightning storms, even micrometeoroids, but none of them quite fit. Still, they offered just enough doubt for the administration to hide behind. To the public, it looked like the scientific process had done its job. But to those inside the intelligence world, it was a carefully orchestrated shutdown that stopped all questions. So who could have done it? The strongest evidence points to an operation known inside intelligence circles as Operation Atlas, a covert nuclear collaboration between two nations that, officially, weren't even supposed to be in the club. Let's start with Israel. By the late 1970s, Israel was already the world's worst-kept nuclear secret. The country had never admitted to possessing nuclear weapons, but it had also never denied it in any convincing way. Its official stance was, and still is, strategic ambiguity. We will not be the first to introduce nuclear weapons into the Middle East, a line that allowed plausible deniability, while warning adversaries that crossing certain lines would be suicidal. But by 1979, the circumstantial evidence was overwhelming. Reports from whistleblowers, including Mordecai Vanunu, a former technician at Israel's Dimona nuclear facility, painted a clear picture of an extensive, highly developed nuclear program. Western intelligence agencies had quietly accepted that Israel likely had dozens of warheads, possibly more. What Israel lacked was a confirmed test, a blast in the open that would signal to the world, and especially to hostile neighbours, that its nuclear deterrent was real and functional. But such a test would carry enormous risk. Israel couldn't conduct it on its own soil. That would be too obvious, too close to regional enemies, too politically explosive. So where could it test a bomb in secret? Enter South Africa. In 1979, South Africa was an international pariah, isolated by sanctions, condemned for its apartheid regime, and slowly becoming more desperate for strategic relevance. It had ambitions of its own. The country was resource-rich, including vast stores of uranium, and its white minority leadership feared both communist insurgencies and the loss of Western support. Building a nuclear bomb was seen as a way to secure leverage and perhaps survival. But South Africa needed help. It lacked the technology and expertise to fully develop and weaponize a nuclear device. And Israel, according to multiple declassified CIA documents, was more than willing to offer support in exchange for something it also desperately needed: a place to test. The two nations found common cause. Their collaboration wasn't theoretical, it was a historical fact. Throughout the 1970s, Israel and South Africa traded missile technology, conducted joint military training exercises, and even exchanged nuclear materials. A 1983 CIA intelligence memo noted, "There is no doubt that Israel and South Africa have cooperated on military projects, including missile development." This is a screenshot of said memo. You can pause the video to read it. One such project was the Jericho missile program. South Africa worked closely with Israel on testing delivery systems, and in return, Israel gained access to the vast Kalahari Desert, where South Africa had constructed 2 underground test shafts by 1977. US reconnaissance satellites even spotted construction equipment and instrumentation around the site, triggering warnings that a test was imminent. South Africa backed down under US pressure, but the intention was clear. Still, the Kalahari was too exposed, too many satellites, too close to international scrutiny. So when it came time to light the match, the two countries likely picked somewhere else: the South Atlantic. Specifically, the waters near the Prince Edward Islands. This area, far from major shipping lanes, devoid of human habitation, and almost impossible to monitor, was the perfect place to disappear a blast. The detection by Vela 6911 was almost bad luck. That satellite, already past its prime, wasn't expected to still be operational. But it was. And it saw the flash. The question then is whether that flash was the result of an Israeli bomb, tested with South African help, or the reverse. Some intelligence insiders believe Israel supplied the device, possibly one of its early tactical warheads, while South Africa provided the location, logistical support, and cover. Others suggest South Africa may have conducted the test as part of its own program, with Israeli advisors on site to observe and calibrate. Either way, it was a joint effort. Further evidence trickled out over the decades. South African naval vessels were active in the test area in the days before the flash. A South African weather ship, the SA Agulhas, was allegedly rerouted nearby, possibly to collect data. And according to investigative journalist Seymour Hersh, intelligence officials at the time privately acknowledged that Israel conducted a joint test with South Africa. Even the phrasing of later diplomatic cables reveals the discomfort inside the US government. Instead of directly accusing either country, officials repeatedly used the term suspected nuclear-capable states. Ambiguity was the rule, not because the evidence was lacking, but because confronting it would open a geopolitical Pandora's box. The Carter administration, already in damage control mode after the Vela detection, could not afford a crisis with Israel. The US had just helped broker the Camp David Accords, easing tensions between Israel and Egypt. Publicly confirming that Israel had tested a bomb, especially with help from apartheid South Africa, would destroy that fragile peace, alienate key allies, and explode Carter's image as a champion of non-proliferation. As for South Africa, Washington was walking a tightrope. Publicly, the US condemned apartheid, but behind the scenes, strategic minerals, Cold War positioning, and a shared fear of Soviet expansion kept the relationship from collapsing completely. Calling out South Africa as a nuclear power would force the US to impose sanctions it didn't want to enforce, and risk pushing Pretoria further into the Soviet orbit. So the political solution? Say nothing. Let the Ruina panel murmur, inconclusive, and move on. But there's one more detail that keeps the theory alive. In the years that followed, South Africa did build nuclear bombs, 6 in total, possibly 7. When apartheid ended, the new democratic government voluntarily dismantled the program, but the design, blueprints, and enrichment techniques matched patterns consistent with Israeli technology. And to this day, South Africa remains the only country to develop nuclear weapons and then fully give them up. Officially, neither Israel nor South Africa has ever confirmed any joint test, but the circumstantial evidence is overwhelming. But not every mystery comes with a villain already cast. While Israel and apartheid South Africa are widely believed to be behind the Vela incident, that theory, however compelling, has never been confirmed. And until it is, the field remains technically open, which means we have to consider the other suspects. Every lead, every motive, every possibility, no matter how far-fetched it sounds at first glance. Let's start with a name that does have a history of nuclear testing: France. By 1979, France had conducted dozens of nuclear detonations, mostly in the Algerian desert and later in the South Pacific. Their tests were often controversial, but never secret. In fact, they were sometimes downright defiant. France didn't care much about what other nations thought of its nuclear program. It believed in strategic independence, no foreign oversight, no begging for permission. So could France have detonated a bomb near the Prince Edward Islands? Logistically, yes, they had the capability. But politically and historically, it doesn't add up. French nuclear tests were always publicly announced, sometimes even televised. They didn't care to hide them. More importantly, France had no reason to test in the South Atlantic. They had established infrastructure in Polynesia, far from the reach of most global sensors. And their last atmospheric test had taken place in 1974, 5 years before the Vela flash, after which they moved their program entirely underground. Nothing in French policy, military posture, or global behaviour at the time suggested a reason to suddenly sneak a test into a place they'd never used before. It just doesn't fit the pattern. Next up, the Soviet Union. Now this theory has a bit more bite. The Cold War was still roaring in 1979, and the US and USSR were locked in a constant dance of deception, propaganda, and military brinksmanship. So, could the Soviets have conducted a secret test to send a message, or to simulate one as a false flag? Technologically, yes, the USSR had the reach, the submarine fleets, and the expertise to carry out an atmospheric test just about anywhere. They also had a history of pushing the envelope, but there are two big problems here. First, the location. The Vela flash was detected near the South Atlantic, thousands of miles from the USSR's naval strongholds. If the Soviets had wanted to test something in secret, they had better options closer to home: the Arctic, remote parts of Siberia, or the Central Asian desert. Testing in the South Atlantic would have been unnecessarily risky, especially with American satellites prowling above. Second, the timing. By 1979, the USSR was engaged in delicate arms control negotiations. SALT II, the second Strategic Arms Limitation Treaty, was on the table. A sneaky test would have torpedoed those talks. It just wasn't worth the gamble. Still, some people argue it could have been a false flag. Perhaps the Soviets were trying to trigger a confrontation between the US and another country. But there's no evidence of such a plan. No intercepted communications. No shift in Soviet behavior around the date of the flash. The theory, while dramatic, is thin. Then there's China. In 1979, China was still relatively isolated from the West, but it had already established itself as a nuclear power. Its last atmospheric test had taken place in 1976, and it was ramping up its underground testing capabilities. While China was not part of the Limited Test Ban Treaty, it was still trying to avoid unnecessary international backlash. A rogue atmospheric test in the South Atlantic would have been not just risky, but geographically impractical. China didn't have the global naval reach to quietly conduct a test in the South Atlantic. They didn't have military alliances in that part of the world. No bases, no logistics, no local assets. If anything, they were focused inward, consolidating power post-Cultural Revolution and beginning a long, slow economic pivot under Deng Xiaoping. A nuclear test far from home just doesn't fit their playbook at the time. What about the so-called rogue states? There were other states in question as well: Libya, Pakistan, and North Korea. Start with Libya. In 1979, Muammar Gaddafi was certainly unpredictable. He had nuclear ambitions and he flirted with every anti-Western cause he could find. But ambition doesn't equal capability. Libya didn't have the resources, the scientific base, or the delivery mechanisms to pull off a nuclear test, let alone one in the South Atlantic. Their program was still theoretical at best. Pakistan had been racing to build the bomb since the early 1970s, especially after India's first test in 1974. But by '79, Pakistan hadn't crossed the nuclear threshold yet. A.Q. Khan's centrifuge network was still developing. While the intent was there, the infrastructure wasn't ready for a functional device, much less one that could be detonated in a remote maritime location. And North Korea, they weren't even in the picture yet. Their nuclear program didn't become credible until the 1990s. In 1979, they had neither the material nor the delivery systems to stage a test of any kind. So then we return to a key question. Even if one of these countries wanted to do it, what did they stand to gain? A successful test would send a clear signal: we're in the club now. But without the ability to follow through, without delivery systems, credible deterrence, or regional clout, it would be an empty gesture. Worse, it would draw instant attention, possibly sanctions, or even preemptive military action. And the risk was just monumental. Getting caught would mean global isolation. None of these states had the political insulation or diplomatic leverage to survive being publicly outed as rogue nuclear actors. That's why, time and again, analysts circle back to Israel and South Africa, because it checks all three boxes: motive, capability, and cover. Israel wanted confirmation that its deterrence worked. South Africa wanted help and strategic leverage, and both had reason to do it in total secrecy. Still, something nags at the edges of this story. What if it wasn't a bomb at all? What if the focus on state actors, on the who, has blinded us to the what? When the US government officially declared the Vela incident inconclusive, it wasn't just being evasive, it was offering alternatives. Natural ones. If it wasn't a nuclear test, then perhaps it was just a weird trick of light, a glitch in nature, something explainable even if rare. That became the fallback line. The White House, under pressure not to implicate allies or provoke international chaos, leaned heavily on a handful of possible non-nuclear causes. At first glance, these explanations seemed to buy the Carter administration time. After all, space is chaotic, unpredictable, and largely unmonitored. But as scientists began scrutinizing the details of the Vela signal, those natural theories started to crumble. Let's start with the government's go-to, the sunlight glint theory. This explanation argued that the Vela satellite's optical sensors, designed to detect sudden bursts of light, may have been fooled by reflected sunlight bouncing off a piece of space debris, or possibly the satellite's own structure, a kind of celestial mirror moment. According to them, the double flash wasn't a real explosion, just an illusion triggered by a strange alignment of angles. But the science doesn't hold up. For one, sunlight reflections do not produce the specific temporal pattern of a nuclear double flash. A nuclear detonation produces two distinct pulses: an initial, ultra-bright flash lasting only milliseconds, followed by a dimmer, slower rise caused by the expanding fireball shockwave. The time between those flashes is precise and consistent, measurable down to fractions of a second. The Vela 6911 satellite detected exactly this kind of pattern. Not just a flash, but a signature. The intensity, shape, and timing of the pulses were in line with over 40 previous confirmed nuclear tests. A sunlight reflection wouldn't mimic that. At most, it might cause a single burst, irregular in shape, with no consistent rise or decay curve. Worse, this particular glint would have had to occur exactly at the same moment the satellite was over the South Atlantic, at a time when the sun's angle was low and the satellite's optical path was stable. That kind of alignment is possible in theory, but statistically negligible. It would be like flipping a coin and having it land on its edge twice in a row. Then there's the micrometeoroid impact theory. This one suggests that a tiny piece of cosmic dust, smaller than a grain of sand, might have slammed into the satellite at high velocity, causing a brief bright flash as the kinetic energy turned into heat and light. But again, this doesn't explain the double flash pattern. A micrometeoroid impact is essentially a mechanical event. It creates a burst of energy, sure, but it's chaotic and short-lived. It doesn't produce a structured light curve with two clean pulses and a predictable gap in between. Also, if a meteoroid had hit Vela 6911 directly, you'd expect some damage or system malfunction. But post-incident diagnostics showed the satellite was fine. No power loss, no sensor degradation, no evidence of impact. The device functioned normally before, during, and after the flash. The third contender, and probably the most exotic, is the superbolt. Superbolts are rare, ultra-powerful lightning strikes that can be 100 times stronger than normal bolts. They can release immense electromagnetic energy and, in rare cases, produce visible flashes even in orbit. Could a superbolt have lit up the sky near the Prince Edward Islands and tricked Vela's sensors? It's possible. But the problem here is location and timing. Weather data from the night of the incident showed no thunderstorm activity in the vicinity of the flash. There were no lightning storm, super or otherwise, anywhere near the region. Vela's bang meters were designed specifically to filter out atmospheric interference, and over their decade of operation, they had never once misinterpreted lightning as a nuclear event. Even if a superbolt had somehow struck the ocean directly beneath the satellite's path, it still wouldn't explain the precise timing and double peak signature. Lightning may be dramatic, but it doesn't flash twice in the calibrated way nuclear explosions do. The physics just don't line up. So what does? Only a nuclear detonation, atmospheric, high altitude or near surface, produces the type of signal Vela 6911 recorded. The optical curve, the ratio between the flashes, the shape of the tail, all of it matches historical data from dozens of tests conducted by the US, USSR and others. And yet despite these flaws, several scientists, particularly those connected to the Ruina panel, stood by the natural explanation. Why? Partly it was political pressure. The Carter administration had made it clear it didn't want a confirmed nuclear event on its hands. A finding that something exploded could derail diplomatic progress, sour arms control efforts, and throw allies like Israel under the spotlight. Which brings us to the final, quiet truth behind the natural theories. They're not really scientific conclusions. They're diplomatic tools, designed not to explain what happened, but to make what happened easier to ignore. Because if the flash was a bomb, then someone broke the rules. And if no one wants to name who did it, the only way out is to say, it wasn't a bomb at all. But not everyone bought it. Not then, and certainly not now. Because when you strip away the politics, the denials, and the PR spin, the physics still stands. Satellites don't panic, sensors don't lie, and nature doesn't flash like that. And while that is true, another question lingered. If it wasn't nature, could it have been manufactured? False flag or false detection? The phrase false flag gets thrown around a lot in the conspiracy world, but in military and intelligence history, it has very real roots. A false flag operation is when one country carries out an action, often violent, while making it look like someone else is responsible. The point is to provoke retaliation, stir confusion, or justify war. And the United States, despite its image as the global policeman, has more than a few of these skeletons in its closet, one of which is Operation Northwoods. In the early 1960s, US military leaders proposed a plan to fake terror attacks on American soil, blowing up ships, crashing planes, even staging funerals, all to create a pretext for invading Cuba. The documents were declassified decades later, and they're chilling. These weren't rogue suggestions scribbled on napkins. They were official Pentagon proposals presented to the Secretary of Defense. They only stopped when President Kennedy flat out refused to authorize them. So if that kind of thinking existed in the 60s, who's to say it was gone by the late 70s? In such, some people believe the false flag succeeded with Vietnam, and that's why the US invaded Vietnam, because of made-up incidents and stories to provoke an invasion. Now fast forward to September 22nd, 1979. A satellite picks up what looks like a nuclear explosion in the South Atlantic. But what if no bomb went off? What if someone wanted Vela 6911 to detect something that didn't really happen? Could the signal have been spoofed? In theory, yes. Consider this. You don't have to fake a flash in the sky. You just have to fake what the satellite saw. That means intercepting the signal, altering the readouts, or feeding pre-engineered data into the analysis stream. It sounds like science fiction, but in the world of Cold War espionage, electronic warfare, and black budget operations, it's not impossible. And who would benefit from such a stunt? Start with the obvious. Those who wanted to frame Israel or South Africa. Both countries were skating on thin diplomatic ice. Israel denied having nuclear weapons. South Africa was facing sanctions and isolation. If someone wanted to create a scandal, undermine their credibility, or force their programs into the open, a fake test would be the perfect trap. What about the Soviets? Could they have staged the signal to embarrass the US or its allies? Maybe, but there's no real gain. It would have been risky, technically difficult, and easy to disprove once the US started digging. Plus, the Soviets didn't seize the narrative after the flash. They didn't weaponize it diplomatically. They were strangely quiet, almost like they were waiting to see what America would do next. And that raises another possibility. What if this wasn't aimed at America, but came from America? Let's say for a moment that a faction inside the US government or its sprawling intelligence network wanted to push the president in a specific direction. Maybe to derail diplomatic talks, maybe to tighten surveillance in the South Atlantic, maybe to reframe nuclear policy. One way to force a response? Trigger a phantom threat. Create the illusion of a test, get everyone spinning, then pull back before real damage is done. It's not just cloak and dagger paranoia. Declassified memos from the late 1970s show deep divisions within US intelligence agencies. Some believed Israel had nuclear weapons and needed to be restrained. Others thought South Africa's growing capabilities were a crisis in the making. And not everyone trusted Carter's soft diplomatic approach. A few hardliners even argued that inaction was making America look weak. Would those kinds of voices be willing to manufacture evidence? History says yes, because some already tried in the past. There's also the money trail to consider. Defense contractors, nuclear labs, and military R&D programs thrive on threats. The Cold War wasn't just an ideological battle, it was a business. Billions flowed into detection systems, satellite upgrades, and missile shields. And every time a new event happened, budgets grew. Oversight loosened. Urgency replaced debate. A single flash in the sky, real or not, could justify months of spending and years of policy. And that's what makes the Vela incident worrying. No one really knows the answer. Even inside the intelligence world, not everyone agreed on what happened. Some analysts insisted the flash was real. Others said it didn't match any known signature. At Los Alamos, researchers reportedly argued behind closed doors about the validity of the signal. At Sandia, some questioned whether the satellite had been tampered with by foreign hackers, unknown systems, or even backdoors written into its original programming. No one could prove anything. So where does that leave us? Legacy of the Vela flash. In the years following the Vela incident, nuclear monitoring got a major upgrade. The US and its allies expanded the use of multi-spectrum satellite sensors beyond simple optical flashes to include infrared imaging, acoustic triangulation, and electromagnetic pulse detection. Submarine networks were expanded to capture undersea tremors that might signal underwater detonations. Atmospheric sniffers began flying more routine missions to catch faint traces of radiological material in the upper stratosphere. But beyond the tech, the real shift was cultural. Intelligence analysts were told, from now on, plausible deniability is not the same as nothing happened. The Vela flash became a mandatory case study at agencies like the NSA, CIA, and DIA, not just as a mystery to be solved, but as a warning. A reminder that the most dangerous events are sometimes the ones everyone agrees not to investigate too deeply. And that includes the White House. The Carter administration's response to the flash wasn't just a political tactic, it became a precedent. In the decades since, the US has faced multiple ambiguous nuclear events, suspected tests in Iran, seismic events in North Korea, and even unexplained bursts in the Indian Ocean. In nearly every case, the response has followed the same pattern pioneered in 1979. Downplay, delay, deflect. Make it uncertain, and move on. Despite global treaties like the Comprehensive Nuclear Test Ban Treaty (CTBT), multiple countries have been accused of small, covert nuclear tests. But no public proof has ever emerged. Why? Because everyone learned the same lesson. Without confirmation, there's no crime. In the end, the truth was buried so deep, behind so many layers of deniability, that even those closest to it weren't sure what they were part of. You see, in the intelligence world, truth is often compartmentalized, literally. You only see what your clearance allows. You can know the flash happened, know where it occurred, even know what it looked like, and still never know who caused it. That compartmentalization is what keeps plausible deniability alive. But it also creates a kind of bureaucratic amnesia. After the flash, agencies passed around blame like a hot potato. The Pentagon deferred to the DOE. The DOE passed it to the CIA punted to NASA. By the time it hit the press, no one had clear ownership, and that was exactly the point. So, if you were to ask me who detonated the nuclear bomb, I would say it was between Israel and South Africa. And yes, that means a nuclear bomb was detonated and was detected by Vela. This story once again makes us question what we really know as the truth. If this story made you question what else is being hidden in plain sight, don't stop here. We covered Operation Northwoods in detail, an event that never happened until the evidence got too loud to ignore. Subscribe, click the bell, and follow the trail before it disappears again. Trail before it disappears again. Trail before it disappears again. Trail before it